So here we are finishing up our foldable about finding the area of quadrilaterals. We had started with looking at the area of parallelogram, and a parallelogram is a special kind of quadrilateral. It has the opposite sides being parallel to each other. Then we moved on to trapezoid, which has two parallel lines, but only two. And then a rhombus has four parallel lines. Here's a set. This one are parallel to each other, and this are parallel to each other. But it's a special parallelogram that has all the sides being equal. And that is the definition of a rhombus. So I want us to look at these arrows here and label. When we go to find the area inside of a rhombus, there's a formula that we use, but we need to know the definitions of things first. So let's call this one, these are diagonals. When you go across something, maybe sometimes you've been at sometimes in busy cities they have crosswalks where, instead of walking this way and this way, they'll just have all the lights, all the cars will stop on all the corners, and then the pedestrians will just walk straight across, they'll walk diagonally across the city block. So diagonal means to go straight across here from corner to corner. So let's call this diagonal number 1. And it doesn't matter which one's which, kind of like with the trapezoid, base 1, base 2. It doesn't matter which one's which, but there's one and then there's the other. Diagonal number 2. Okay. So, especially if your writing's big, mine's kind of big, probably going to run out of room if I write my formula here. Remember when we're working with geometry and formulas, we want to end up with everything lined up. We learned algebra first, so we could use algebra to solve these geometry formulas. So here's the formula for the area of a rhombus. The area of a rhombus equals diagonal number 1 times, we're going to use a dot for times, diagonal number 2. So this length times that length, and all of that, the product of D1 and D2 divided by 2. That's the formula to find the area inside here. So let's come down and practice with a real example. So here we have, it's just turned a different way, right? It's like this one, but maybe this one diagonal is a little bit shorter. It seems a little more pinched in this direction. So we're always going to start with the formula. Area equals D1 times D2, all of that divided by 2. We want to end up, we're not going to be doing algebra sideways. We want to end up with it all lined up where equal signs are lined up here. Remember, we're not jumping things from one side of the equation to the other. And again, it does not matter, dealer's choice, whatever you'd like to be diagonal 1 or diagonal 2. Let's see. I'll just do the straight across one as diagonal 1. So area equals 12 times diagonal 2. That's going to make it, the other one is 18, and all of that divided by 2. It's, they're centimeters. When we finish, centimeter times centimeter is going to be square centimeters, because areas, that would be all filled in with tiny squares. We'll get to that part at the end. So area equals, so 12 times 18, I've done this one before. I know that that is 216 divided by 2. So area equals, and you probably don't need a calculator for this part, although you might have noticed my notes so far on your weekly checkoff. If you love a calculator, you're going to love this geometry unit, because you get to use your calculator on everything, on your homework, on quizzes, on tests. But this is one you can probably do in your head. What's half of 2? It's 1. It is. What's half of 16? It'd be tempting to put 8. We need to put 0.8. And if we want to check, if we double 100, it's 200. If we double 8, it's 16. So area is 108, but we can't stop there. We talked before that the units are centimeters. And then when you're multiplying centimeter times centimeter, it's square centimeters. So if that were filled with tiny centimeter by centimeter squares, you would be able to fit 108 in there. And that, my friends, is how you figure out the area of a rhombus.